Welcome back to another tutorial on R programming for beginners. I'm Harry Norton, this is Harry Does Data, and today we're going to be looking at one of R's most popular features and something that we've been building up to this entire series, plotting. Data visualization is key to allowing us to effectively communicate our story, and R has many devoted libraries and functions for data visualization. In this session, we're going to be looking at those that are included in the base R package. These allow us to plot a variety of graphs, including scatter plots, bar plots, histograms, box plots, and density functions, amongst many others. The customizability of these plots is where you really start to see the power of using R over another data visualization tool. So, let's get into it. But just before we do, don't forget to give that like button a quick tap and subscribe to my channel so you don't miss out on more great data science content. So, plotting using the base R packages. As you can see, there's no me on the screen this week. When we do our plots, they're going to appear down in the right hand corner here, and I don't want myself to be in the way of our lovely plots. So in order to do our plotting, we're going to use one of the built-in R datasets that we looked at last time. And the one we're going to be using is the mtcars dataset. So let's just have a look at that to start with by running mtcars. So this is essentially a data frame with lots of different cars within it, and then a few different data points for those cars. So the ones we're going to be sort of interested in today are the fuel efficiency, the number of cylinders, the displacement of the car's engine, the horsepower of the car, possibly this one, which is the time to do a quarter mile in seconds, and the number of gears the car has. So to work with this, I'm just going to assign it to a data frame within our environment. So let's just assign it to an object called C data frame, cars data frame. And now that's up here in our global environment. Now, the first graph we're going to look at plotting in R is the scatter plot. So we could do something like plot the fuel efficiency of a car against the displacement of its engine and see if there's any relationship between those. So to do this, all we have to do is use a plot function, and we set x is equal to one of these variables. So x will be the independent variable, the variable that we are changing to see how the other variable reacts. So that will be the displacement. So if we select the C data frame, and from that we want the displacement. So displacement, and then we will set y equal to the fuel efficiency, or the MPG. So C underscore data frame, and then we want the MPG. And that's as simple as that is. If you run that, then you'll get a nice plot over here of the displacement against the fuel efficiency. Now, as I said in the intro, one of the best things about the R plotting software is the customizability of these graphs. You can essentially customize anything about this graph, from its titles, its axis labels, the points that make up the graph, whether it has grid lines, and many more things. We're just going to look at some of the most common ones today, and we're going to try and make this graph look a bit nicer. So if you want a list of some of the things that you can customize about the graph, we could do just a quick question mark plot, and we'll look at the default scatter plot function, and you can see here some of the arguments that you can give the function plot. So just to pick out a few, type defines whether it is a simple point plot or whether you have lines between those points. Xlim and ylim define the limits of the x and y axis. Main defines the title. Xlab and ylab define the labels for the x and y axes. And there are many more ways that you can customize the graph. And as I said, I'm not going to be able to go through them all today, but this would be your first port of call for things that you can customize about the graph. And there are many other things that you're able to do. So if there's something that you want to do, but you can't see it in this information here, or I don't do it in this tutorial, just leave me a question down in the comments, and I'll try and get back to you about how you would do the thing that you want to do. So let's start with how you would go about changing the title of the graph. Now you'll see here, I've got the same function as we had above written out, but you can actually write functions out over multiple lines. So basically anywhere that you put an enter in a function, it doesn't actually affect it. As you'll see, that runs exactly the same. And the reason I've done this is it makes it a lot easier to see the different arguments that you're defining. So when you come to making graphs, you'll define many arguments in some cases, and it just gets a bit messy if you have them written out over one line. So you'll see we've got the data arguments defined already, and now we are just going to add the main argument, and we're going to make that equal to engine displacement versus fuel efficiency. And you'll see that this has to be given as a character data type to the main argument. And if we run that, you'll see that our graph is replotted and it now has the title. The second thing that we might want to do is make these X and Y labels a bit neater. At the moment, that's not particularly readable. Yeah, you can just about make out that that's the displacement and that's the MPG, but we can make them a lot nicer. So as I go through each of these steps, I've just got the previous step pre-written out so that I don't have to type it all out again, but I can still have it under these headings. In reality, I could just add my next argument up here. For the purpose of this tutorial, I just wanted to have these headings in here, so I'm just going to leave it like this, and we can define our arguments as we go. So we need to define two arguments, xlab, and our x label is engine displacement. And don't forget your units, that is measured in cubic inches, I believe. So cubic inches. And we also need to define ylab. So ylab is equal to fuel efficiency. And that is measured in miles per gallon in this case. So now if we run that, then nothing happened. And that is because I missed out this comma here. So now if we run it, you'll see that the labels are added to our plot. Now at the minute, our plot's a little bit boring. There's not a lot of color involved. To change the color of the points that are plotted on the graph, we simply define the col argument. And there's a few ways that you can define what the color is. There is essentially a list of colors, and I'll show you how to get that in a second. And each of those colors is also sort of indexed. So you could just define a number. So the standard number is obviously 1. And then if you just move through the numbers, then you'll see that you get different colors. But you can also define the color using a word. So we could just say blue, and you'll see that we get the points in the color blue now. Now, if you want a list of the colors so that you know which ones you can use, you simply need to run the colors function like this, and you'll see we get a list. And so it appears the indexes, so using like 1, 2, 3, 4, don't correspond to this list in particular. So this just tells you what colors in alphabetical order you could use. And so you'd have to define them using the words. So we'll just switch that to a nice, should we say dark cyan? Dark cyan. See how that looks. That's better. Okay, so we'll leave it like that for now. Now, something else that you might want to change is the size of these points, and that is done using an argument called the character expression, which is simply CEX. The standard point size is 1. If you want anything larger, then you need to go higher than 1, obviously, so we could go for 2. And if you want to go any smaller, then you need to go for a fraction, so we could go for 0.5, and that would be half-sized. But let's just stick with 1 for now, because I think that looks best. And then move on to the point character argument. So this is essentially to change the actual character that the point is made of. So this argument is defined using PCH. And again, the options for these characters are defined using just an index number. So let's just go for 3. And you'll see we now have plus signs as the character. Or let's try 4. And you'll see that we now have crosses. And if you want a list of the different point types for this, then you can simply do $PCH and run that one. And if you scroll all the way down, you'll get to this point where you'll see there's a list showing each of the indexes and their corresponding point characters. You can actually use a lot more than just these characters, and they're defined here. So I'd probably just give it a quick Google if you want to see what any of these characters actually look like. So if we just go back to our plot, on a scatter graph, you might also want to show some different groupings. So we could group this data by the number of cylinders that each car has. And if we just go back to our data frame, you'll see the options for this are 4 cylinders, 6 cylinders, or 8 cylinders. And so what we could do is we could give each of these points a different character depending on which of those groups it falls into. And to do this is quite simple. We simply need to supply the PCH argument with a vector. So if we just quickly take a look at the C data frame and just the cylinders column, if we run that, you'll see you get a vector of all the values of the number of cylinders each of these points has. And so if we supply that vector directly to this argument and run that, you'll see that each of the points is updated to have a different character based on how many cylinders that car has. Now, the way that this has actually worked, as you can see, is if a car has 6 cylinders, then it has been assigned the PCH value of the index 6. So if I just change this to 6, you'll see that they're all given the triangles. If it has 8 cylinders, then it's assigned the value corresponding to 8, which is the star. And if they have 4 cylinders, it's assigned the cross. So if we just go back to it being assigned depend on the number of cylinders and run that, then you'll see that's how it's done. We probably want some sort of legend to define what each of these different characters means. And we can do that simply as well using a legend function. So we're no longer defining arguments within our plot function. To add a legend to an existing plot, you then have to use a legend function. So legend, and if we just quickly do a question mark legend to look at the help file, you'll see there's many arguments that you can define for the legend, but the ones we're particularly interested in today are the X and Y, which define the location of the legend. And you can do this in several ways, but I'll show you how we're going to do it today. So we'll define the X argument using a character string. So what we can do is just type something like top right, and that will unsurprisingly put the legend in the top right of our graph. You can also use the X and the Y as coordinate values to define more specifically where you want your legend to be. So let's also define a legend argument. And this is just a vector of the values that we want within the legend. So we want 4, 6, and 8 because we want to define how many cylinders each of the points has. So we can just do 4, 6, 8. And now if we just quickly run our graph again and now run the legend function, you'll see that this legend is created in the top right with the values 4, 6, and 8. But we now need to define the PCH argument to assign each of these a character. So PCH equals, and then again, because of the way that we did this up here, it's just going to be the same vector that each of these is assigned. And you'll see now that we can clearly see that the 4-cylinder car data points are represented by the cross, the 6-cylinder by the triangle, and the 8-cylinder by the star. And just as you'd probably expect, the 4-cylinder cars are at the low end of the engine displacement spectrum here, the 6 in the middle, and the 8 at the top. And we can also nicely see on our graph this trend of decreasing fuel efficiency with increasing engine displacement, which again is to be expected. So our graph is looking quite nice now. There's a couple of other things that we might want to know how to do. So let's suppose that the government has brought in a minimum fuel efficiency where if a car is not above that fuel efficiency, then it is illegal. So we might want to plot a line on this graph to show which cars are legal and which cars are not. And let's just say that that fuel efficiency value is, say, 18. Now to plot a straight line like this, we can simply use an AB line function. And so all that's doing is plotting a line from A to B. So because we want a horizontal line, we can simply define a height for that line. So let's say that height is equal to 18. And if we run that, you'll see that we get a horizontal line at 18. Now you can also define a line type in here to change the type of the line, but you will have to replot the rest of your graph to then overwrite the line, and you'll see we now have a dotted line. So there's our nice scatter graph. As I said before, there are many other ways in which you can customize these graphs and other R packages where you can create even fancier, better looking graphs. So I'm going to end that tutorial there. It's getting quite long and there's still quite a lot to go through. So that's it. We've looked at the base R package and we've plotted a scatter graph and looked at many of the different arguments that you can change for that plot function. But next time we're going to go through some of the different types of plot that you can plot in R and how you export and save graphs as well. So thanks for watching this one. If it's been useful for you, then please give this video a like and subscribe to my channel, and see you next time.